In this video, we're going to explain what inverse variation is all about, and we're also going to complete an example. Now, you may remember back in the Year 11 course, we covered a topic which was called direct variation. And the equation we used for this was y equals kx. Now, we noticed with direct variation that when one variable increases, the other variable increases with it. For example, if x increases in value, y will increase in value as well. Alternatively, if one variable decreases, the other decreases with it. Now, inverse variation has the opposite effect. When one variable increases, the other will actually decrease. The inverse variation formula is below. It's y equals k over x. Now, some of you might have noticed that this is basically the same as the reciprocal function we spoke about in earlier videos. Now, whenever you get a problem that involves inverse variation, you'll usually get a comment such as y being inversely proportional to x. Whenever you see something like this, you know that you're going to use this formula and that it's a problem involving inverse variation. You'll see here that k is known as the constant of variation, which is quite an interesting statement because constant and variables are basically opposites to each other. Constants always stay the same and variables always seem to change. And I guess the reason they've called it this is because k changes from question to question. So whenever you're given a new question or a new problem, you'll get a new value for k. But once you have found k, it will remain constant throughout the question. Now, to calculate k, we simply substitute values for x and y first and then solve for k. Now, I'll show you how this works in example 1. In example 1, it says y is inversely proportional to x. As soon as I see this statement, I know that I'm using the formula y equals k over x. I'm also told that when y equals 10, x will equal 3. So we'll move on to question A. It says calculate the constant of variation k. So what I'm going to do is I'm going to copy my formula down, y equals k over x. And I mentioned earlier that in order to calculate k, we simply substitute values for x and y first and then solve for k. Now we know that when y equals 10, x equals 3. So we'll write that down. When y equals 10, x must equal 3. So we don't know what k is yet, but we can multiply both sides by 3 to cancel the 3, giving us 30 equals k, or saying that k equals 30. K being the constant of variation. Now, as soon as you've figured out k, you know that it will remain constant or will never change throughout the question. Because of that, we can change our equation to y equals 30 over x, because we now know that k is 30 and we know that it's constant. It's not going to change. When we get to question B, it says calculate y when x equals 5. We now have a new equation or a new formula to use. Y equals 30 over x. And if x is 5, well, y must equal 30 over 5. And 30 divided 5 is 6. Let's now move on to question C. We now have a new formula for y. Y equals 30 over x. And we know that y equals 1.5. So we'll rewrite it as 1.5 equals 30 over x. Now, in order to find x, we need to take a couple of steps here. We need to multiply by x first in order to cancel x. That will give us 1.5x on the left, since 1.5 times x is 1.5x. And since we cancelled the x on the right, we're going to get 30. Now we're in a better position to solve for x. x. We're just going to divide both sides by 1.5, which cancels the 1.5 so that we can find x. X will be 30 divide 1.5. On our calculator, 30 divide 1.5 gives us an x value of 20. Anyway, that concludes our video introducing inverse variation and also completing an example. Remember to read the description below for links to workbooklets that relate to this video.